All right, so in this lesson, we're going to look at using vectors to find the shortest distance that something moving is away from a specific point. So like you see here, it kind of looks like a coastline. You have green for the ground and blue for the water there. And you have a ship that is sailing through a point A in the direction of vector B. So you see that line that the ship is sailing along. And there's a port P. And we want to figure out when the ship would be closest to the point. Okay, now this problem doesn't have numbers with it, so we can't actually figure it out exactly, but we can at least understand the concept. And the key concept here is that in order to be closest, it's got to be, our path to that point is going to be perpendicular to the path that the object is traveling on. Okay, so here we see AR, and if we were trying to find the shortest distance from P to this line, okay, we would measure here where it makes a 90-degree angle. Okay? So I know it says R over there. We could call this like R prime if we wanted. But that would be the point where the ship is closest. Okay? Maybe this port is too shallow and the ship can't come in, so we've got to take stuff out to it. So we don't want to travel any further than we have to, so we want to figure out when is it going to be closest. Okay? When they take stuff up to the International Space Station, they don't want to send someone up there when it's as far away as possible. They want to send it up there when it's pretty close, so they have to use less fuel and it's a shorter trip and everything. Okay, so there's a number of different types of applications that you could use with this, but the main thing here is that perpendicular idea. Okay. And I want you to think about this. In order to be perpendicular, what should come to mind as we're studying vectors? Okay, a right angle is perpendicular, but think about vectors. When
direction?
That's it. The dot product equaling 0, okay? Thinking about vectors, right angles, when you hear a right angle, in the context of vectors, the dot product equaling 0 ought to be the thing that pops into your head. Okay? And as you can see here, we would find this vector from P to wherever R was, wherever the ship is, and we would dot it with the direction vector that the ship was going. So in this case, it's vector B, and that dot product needs to equal 0. The point... This is a term that you should be familiar with just so you know what to look for. If they ask you for the foot of the perpendicular from P to the line, they're looking for that point R when it is going to be a perpendicular. Okay? In our case here, R was moving along this line. Okay? We want the specific R when it's perpendicular. Okay? So let's actually do an example of this, and we'll kind of learn a process here for solving these. Okay? Now, here we have a line that has a vector equation, xy equals 1, 2, plus t times 3, negative 1, where t is a real number, and p is the point 5, negative 1. And it says, find exactly the shortest distance from P to the line. So here's what we want. I'm gonna first of all sketch what's going on here. So we have here this line. It starts at the point 1, 2. And it goes along a vector of 3, negative 1. So it's going to go to the right 3 and down 1. And then to the right 3 more, and down 1. Okay, and we can see here This is the line that we're talking about. Well, point P is the point 5, negative 1. 1, 2, 3, 4, 5, negative 1 is right here. Okay? So what we need to do is we need to find this, we often use R, we need to find this point R that will make PR be perpendicular to the line. Okay? Does that make sense? Now, question, what vectors are we going to use to make them perpendicular? You don't need numbers at this point, but just in concept even. What vectors are we going to use? The velocity vector of the line. Good, that's one of them. What is the velocity vector of this line? The line. xy equals 1, 2 plus t times 3, negative 1. What's our velocity vector?
3, negative 1.
It's 3, negative 1, okay? So we've got to use the velocity vector. Okay, 3, negative 1. And then what other vector are we going to try to make perpendicular to that?
The direction. Like first one, the direction. Like the 1, 2.
1, 2 is in a direction vector. Remember, that's our position vector at time 0. We don't know the numbers yet. That's what we got to find. Okay, but what vector, if you look at our drawing here, are we going to use? You're thinking too hard. What needs to be perpendicular to the line?
The vector PR.
PR, there we go. Okay, PR. We want vector PR to be perpendicular to the velocity vector. Okay, so PR dotted with V is going to equal 0. Okay? We're overthinking a little bit, I think. All right? Use the picture to help you. All right, so I've given you a couple of key steps that you can use. I don't typically give you step-by-step methods, but this one, you know, it helps. The first thing that we're going to do is define what this point R is. Okay? Now, we know it's a point on the line. Okay? We know it's a point on the line. This is where our parametric equations are useful. Okay? What are the parametric equations for the line?
1 plus 3t. Well, x equals 1 plus 3t.
Good. X equals 1 plus 3t. And?
Y equals 2 minus t.
2 minus t. Okay. So, we've got those two. Every x coordinate has a 1 plus 3t, and every y coordinate is 2 minus whatever the time is there. So, we're going to define point R as the point 1 plus 3t, 2 minus t. Okay? We just use the parametric equations as the x and y coordinates. That will make sure that that point ends up on the line. Is everyone with us so far? Okay? Alright, so now, here's the deal. We know what vector v is. Remember, our goal is to get a PR so that when we dot it with v, we get 0. Okay? We know what vector v is. We don't know what vector PR is. But we do know what point P is, and now we know what point R is, so we can find vector PR. Okay, so PR, if you remember to find the vector between 2 points, you take the coordinates of the point you're going to, in this case 1 plus 3t and 2 minus t, and you subtract the coordinates of the point you're coming from. We're coming from P, which is 5, negative 1. So it's 1 plus 3t minus 5, and 2 minus t minus a negative 1. So now we know vector PR is a negative 4 plus 3t and 3 minus t. So now we've done the hard part. At this point, we already know what equation we need to use. Now we just need to use it and interpret our answer, or use it to find our answer properly. Okay? Alright, so let's actually do our equation. We want the dot product to equal 0. So 0 equals PR dotted with V. I just found PR to be a negative 4 plus 3t and 3 minus t. And I'm going to dot that with 3, negative 1. Okay? So, 0. Now it's just a simple equation to solve. We do the dot product, solve for t. So it's 3 times a negative 4 plus 3t minus 1 times 3 minus t. And we solve that equation. Alright, so we got a negative 12 and a minus 3, that's negative 15. I'm going to bring that over here. So 15 equals 9t plus another t is 10t, and t equals 1.5. You guys can do the algebra, no problem. Alright, but here's the key. We found that t is 1.5. And at this point, we could figure out a couple of different things. We can figure out what point R is. Okay? Point R, we know is 1 plus 3t and 2 minus t. Okay? Well, if I have t is 1.5, 1.5 times 3 is 4.5, plus 1 is 5.5. And 2 minus 1.5 is 1/2. So point R is 5.5, 1/2. Okay? I can also figure out what vector PR is now. Negative 4 minus 4.5 is negative 1/2. Or I should say, hang on, negative 4 plus 4.5 is a positive 1/2. Let's try this again. And 3 minus 1.5 is just 1.5. So that's vector PR. Well, let's remind ourselves, what is our goal here? What are we trying to find?
Find your PR, the distance of PR.
I read the problem again. Wait, what'd you say?
The shortest distance of PR.
The shortest distance, okay. Now that we know R, we know vector PR, what is that actual distance? The magnitude, okay? So now we're finally able to answer the question here. What is the magnitude of PR? Okay? And you guys know how to find magnitude. It's the square root of 1/2 squared, which is 1/4, plus 1.5 squared, which is 9/4. So that's the square root of 10 over 2 if you simplify it. And notice it said exact, so we are not going to round that at all. We're going to leave it as a radical, root 10 over 2. Okay? Questions? Now that seems like it took a long time. Alright? For one thing, once you get the hang of it, this really goes quickly. Okay? For another thing, our only other alternative would be, first of all, recognize the velocity as a slope, then take the opposite reciprocal slope, then find the equation of the line through the 0.5, -1, then intersect it with the current line that we have, then, once you have the intersection point, then you could find PR, and then you would find the magnitude. Okay? So this way, all we have to do is find the vector. We don't need to find the equation of another line or anything like that. Okay? So this actually is a pretty efficient way of finding what we're looking for. Okay? So, let's try the process one more time, and I'm going to have you guys try the process once on your own. Okay? Let's do 1A together real quickly here, and I'll kind of do it a little bit faster this time. Okay? The first thing that we're going to do, if we want the shortest distance from P32 to this line, the first thing we're going to do is find R, which is 2 plus T, and 3 plus 2T. That's our point. So now we can find vector PR. Okay? Vector PR is 2 plus T minus 3, and 3 plus 2T minus 2. So that's T minus 1, and 1 plus 2T. So T minus 1 and 1 plus 2T. Okay? So I've already done quite a few steps here. We found R, found the vector. Now, we need to find the dot product between PR and the velocity vector. What is the velocity vector in this equation? Or this set of parametric equations? 1, 2. Okay? That 1 and 2. Okay? Remember, the components of the velocity vector are the coefficients of t. Okay? So now I'm going to dot these two together. I've got t minus 1, 1 plus 2t, dotted with 1, 2, and that needs to equal 0. So, 1 times t minus 1 is t minus 1. 2 times 1 plus 2t is 2 plus 4t. That equals 0. And I get, if I keep solving this, t equals 1/5. Negative 1/5, sorry. Okay? So t is negative 1/5. What do I do at this point? Find the magnitude of PR. So I've got to plug t into PR. Okay. Now I know that if t is negative 1/2, I've got negative 1/2 minus 1. So that's a negative 1 and 1/5. I said half. It should be negative 1/5. So it'll be a negative 6/5. And 1 minus 2/5 is 3/5. Okay? That's our vector PR. And now it's just the magnitude of that. Okay? So that, of course, is the square root of 36/25 plus 9/25, which is the square root of 45, which is 3 root 5 over 5. You guys know how to rationalize. Okay? So that's the magnitude of PR, and that is the shortest distance. Okay? So, like I said, once you get the hang of it, there's a number of steps here, but it's really not all that complicated. The key is just remembering how to define R and find vector PR. Then you're just doing the dot product equal to 0. So now that we have that one, try this next one here. The point S is 5, -2. Find the shortest distance to the line xy equals 2, 5 plus t times 3, -7. All right, for time's sake, how did you guys start?
Right. So we
Okay.
made R, the x coordinate is 2 plus 3t, and then the other one was 5 minus 7t.
Okay.
Right? And then we did the vector s to r. So that was 2 plus 3t minus 5 for the x coordinate.
Okay.
And 5 minus 7t plus 2 for the y coordinate.
Okay.
Which equals 7 minus 7t. And
All right, good.
dot product, not part like that. I used it.
Okay. So there's our vector. What are we doing the dot product with?
The vector.
3 over 7.
3, -7. Okay. So we're going to find the dot product of 3, -7 with what we just got, -3 plus 3t and 7 minus 7t. And that should equal 0. All right, so what do we end up with?
Yeah, I get t yet. Anybody get t?
-9 plus 9t minus 49 plus 49t equals 0. So you get 58t equals 58. So t equals 1. Okay? So now we plug it in, and we get SR equal to, what do we get SR equal to? 0, 0.
No, 0. Yeah.
What does that mean?
How?
That means. That means. Does that mean? Wait a second. Just
That means it's just on.
Does it mean that's on?
Wait, what?
It's just like the x-axis.
Is it on the vector?
no.
It's the origin.
Wait, no.
Is it on the vector that we were dealing with?
The point that we've got, 5, -2, is on the line. So what's the shortest distance?
It's nothing.
0. All right? The shortest distance from the point to the line is 0 because...
Work for like nothing because we just find it on the line.
Yeah. Well, think of it, remember we're talking about a moving object. Here's 5, -2, and here's something like moving along the path of the line. It's getting closer, 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 and finally it hits it, and then now it's moving away. So the closest distance would be 0, because it actually hits the point. Okay? All right, so finally, the other case that we've got here is, what if we're not given the equation of the line that something is moving on? Okay? In this case here, we have a ship. Ship R is moving in the direction 3, 4 at 10 kilometers per hour. Write an expression for the position of the ship in terms of t, the number of hours after leaving port A. Now question, is 3, 4 have a magnitude of 10? No.
It has a length.
Which is have to find 10.
What's its magnitude?
5.
It's 5. Yeah.
It's 5. So what is the actual velocity vector of ship R? If 3, 4 has a magnitude of 5, and we want it to be a magnitude of 10, it's 6, 8. There we go. Okay? It's 6, 8. So there's our velocity vector. And now we can write our equation. The point xy is going to equal, what's our starting point? Looking at the picture here.
Negative 8, 3.
Negative 8, 3. Okay, so negative 8, 3 plus t times 6, 8. Okay?
Is that what they're asking for in question A?
That's what they're asking for in A. That's correct. Okay? So now part B is exactly the same thing that we already did. Okay? So the question is, what if we're not given the equation of the line? Well, find it. Okay? Find it. But be careful about the velocity. If it's a case like this where you're told what the speed needs to be, convert that direction vector to a velocity vector. This is where there is a fine difference between just a direction vector and an actual velocity vector. Okay? So, that's, if we're not told any difference, we can usually assume that the direction is the velocity. But here we're told that the speed actually is something else. So we need to make the velocity vector be the correct magnitude first. Okay? Now we're just going to follow the same process using that point 10, 2 and a random point r on the line. Well, that's negative 8 plus 6t and 3 plus 8t. Alright, find your vector, dot product it with the 6, 8. Set it equal to 0, solve for t, and then you find the magnitude of your vector. Okay? So the same thing that we've done the last couple of times. Alright? Not too bad once you get the hang of it. Tomorrow we'll do it in 3D.
Yay.